Hello, thank you for the opportunity to present to you today. My name is Joe Buckler. I'm the Vice President of Sales and Business Development for the Babcock and Wilcox Company. And today we'll be talking to you about some of the carbon capture technologies that B&W has developed, as well as energy storage options that you may want to consider for your plants and facilities. At your plants and facilities, you've probably operated B&W's subcritical or supercritical coal-fired boilers. You may have environmental technologies at your site that B&W has developed to help support regulations in your state and federal governments. And you may even operate B&W's Diamond Power soot blowers. All of these technologies have been developed starting from an R&D process at some point in our history until they've gotten to full-scale operation as you see today at your plants. Our carbon-friendly technologies are no different. Today we'll be talking about three specific technologies. The first two are bolt-on to existing or new boilers within your fleet, oxy-fuel combustion and RSAT post-combustion. The third, chemical looping process, is one we're very excited about that we'll get into a little bit more detail on today, and one that requires kind of a separate footprint at your facility. These three carbon capture technologies can handle a wide range of fuels and therefore can be very flexible for the needs that you have within your organization's sustainability goals. B&W is a leader in oxy-fired combustion. We have demonstrated up to a 30 megawatt facility for oxy-fired combustion, and this product is ready for full-scale deployment on a large subcritical or a small supercritical boiler. Oxy-fired combustion in and of itself is simply taking air and separating the oxygen from the air and utilizing that oxygen as the combustion means for your process. This leads to a much more pure CO2 stream at the back end of your process that can then be sequestered and captured for other use. RSAT is the B&W trademark for post-combustion carbon capture. B&W has developed this RSAT process in conjunction with other partners over the past few decades. And this RSAT process is very similar to some of the other processes that are out in the industry, whereas your flue gas at the back end before it goes up the stack is scrubbed, the CO2 is removed, and then can be utilized for sequestering or other beneficial use as appropriate. Chemical looping, however, as I mentioned, is a completely separate process in and of itself. Chemical looping, the terminology in chemistry is not new, right? This is a process that has been in development for over 100 years in some ways, some in different ways, shapes, and forms. However, B&W has worked closely with The Ohio State University to develop chemical looping in support of the energy industry. We're very excited about this process as it can take any consistent carbon-based fuel, bring it into a process, and produce many different forms of energy out the back end. As we consider many different ways in which we're going to accomplish a carbon-friendly world, having the flexibility to develop many different processes or different fuels is exciting to us and hopefully exciting to you as well. So chemical looping would take, in this case, coal, natural gas, consistent biomass fuel, biogas that has been developed from some other process, petcoke from oil and gas and refining industry, and puts it into this process, and the output of the process is then steam for process or turbine, depending on the facility that you're working on. Gasification, especially to hydrogen, which we're very excited about, and we know that hydrogen is important to the future of our energy industry, as well as potentially a syngas that can be used to create other fuels, including methanol. Within this chemical looping process, carbon dioxide is then isolated and can be captured and sequestered. So what is chemical looping? Very simply, there is a particle that is looped through a process of oxidation and reduction to achieve the energy development that we're trying to achieve with this process. In our case, in our partnership with The Ohio State University, the particle is iron oxide. And that iron oxide is looped through a reducer and a combustor in the simplest version of chemical looping to develop steam for power or steam for process use. In the development of hydrogen, an extra step is added to the process, again with the iron oxide as the chemical looping particle, and hydrogen is then produced as well as steam for power or process, as in the previous slide. The development of this hydrogen could then be utilized for combustion or sent to another process for the development of fuel cells. Hydrogen in and of itself is obviously a very green fuel, with the output of a hydrogen combustion process being water, and therefore we're very excited about the utilization of chemical looping for hydrogen development. From a scale-up process, this started in a laboratory just like all of the other products that B&W has offered over the years. It stepped up to 85 pounds per hour, very small next step up. And then we moved up to a 250 kilowatt thermal R&D facility for the chemical looping process. These scale-ups have been very successful. The iron oxide particle that we are utilizing in conjunction with The Ohio State University has proven to be one of the most effective particles in the chemical looping process within the industry. And therefore, we are now ready to take it up by another factor of 10 to a 2.5 to 25 megawatt scale to be utilized to produce this energy. This means that your subcritical and supercritical units may not be able to be replaced, but as additional energy source within your facility, especially with the development of hydrogen as an output, this could be something that you and your companies would be very interested in support of your green energy goals. Finally, B&W recognizes that energy storage is an important part of the green initiatives for many of your companies. Because of that, B&W has partnered with EOS Energy Storage to offer a unique battery solution within our industry. As many of you know, lithium ion is the most common material utilized for batteries in our industry today. The downside to lithium ion is it runs at a very high temperature and requires expensive cooling equipment to keep the temperature down and reduce the risk of combustion and fire within your facility. EOS, however, offers a zinc battery solution. The zinc battery operates at a much cooler temperature without the use of expensive cooling materials in order to keep the temperature down. We find this to be a very important differentiator for EOS in the market. In addition, the EOS battery is very flexible from a storage standpoint, supporting a few megawatts to a few hundred megawatts as required by your particular application. And it also can be very flexible in its layout to support very different footprints around the world. We're very excited about this EOS technology and look forward to talking to you about it in the future. Thank you for the opportunity to talk about B&W's decarbonization platform and our partnership with EOS Energy Storage.